first principle.
Exactly. So what we need to do is, since we don't know apparently what the zero sine x is, like we're trying to prove it, we would have to use first principles.
Yeah.
Which means then that we will be taking the limit as h approaches 0.
Yeah.
Of f of x plus h minus f of x over h. And that means you're going to take the limit as h approaches 0 of sine of x plus h minus sine x over h. Yes?
Yes.
Now, do you know how to take a sine minus a sine?
Like,
So we have kind of done this before, quite some while ago, but you might not be thinking about it. And it's,
so it's sine x times cosine h, like this kind of.
that kind of thing, yes. So basically we're going to rely on the sum or differences to products. Yes, exactly. So you can see how things kind of get a bit sort of more hairy and more difficult, right? You're just drawing in concepts you've done before, that with no hints, right?
Yeah.
So this would therefore rely on the fact that your sine, A minus sine of B is going to equal 2 cosine of A plus B over 2, and your sine of, A minus B over 2. Yeah. And if we use that, and the reason we use that obviously because, we don't really know how to find these limits very easily, but, if we change it, we can then change it to 2 cosine of x plus half h times sine of half h all over h, yes?
Wait. So how do we just change to this equation?
Well, do you agree that this is correct?
Yeah. I
So A is x plus h, B is x, right?
Yeah.
So the 2 is just the 2. So if I add x plus h and x, I get 2x plus h, but I need to divide by 2.
Oh.
There's a divide by 2 inside.
Yeah.
So 2x plus h all over 2 is, x plus half h.
Yeah, that kind of makes sense.
And when I do, so we can write out a bit more working. I'm just wary of space, but I think I can sort of minimize it. So let's write out a little bit more working. So using what we've got up there, so using what we've got on the right, we now have the limit as h approaches 0 of 2 times the cosine of x plus h plus x over 2 plus the sine of, x plus h minus x over 2 all over h. Yes? Which is the limit as h approaches 0 of 2 times cosine of, 2x plus h over 2 times the sine of h over 2 all over h. Does that make sense?
Yeah, actually, I still can't really understand because I understand number 2, but I don't know how to apply that into the.
Right. So maybe I'll do it on a new page, yeah?
Yeah.
So what we've got here is, we've got, what we're trying to work out is, ignoring the limit, we just got the numerator, which is sine of x plus h minus sine of x all over h, right?
Yes.
And we have the formula that sine of a minus sine of b must equal 2 cosine of a plus b over 2 times sine of a minus b over 2. So this is a. This is B.
Oh. Yeah, so that makes sense now.
So A plus B over 2 is going to be X plus H plus X over 2, which is, 2X plus H over 2. A minus B over 2 would equal X plus H minus X over 2, which is H over 2.
Yeah, that makes
Okay.
sense.
So that brings us to this line. Now, you might not understand why I do this, but let's just separate it out first. So this is the limit as h approaches 0 of cosine of 2x plus h over 2, right? Times 2 times sine h over 2 over h. I mean, I've just rearranged it, right?
Yeah.
Now, you probably remember from your limits that the limit of a product is just the product of the limits, yeah?
Yeah.
And now just think about this, right? If h goes to 0, right?
Yeah, so it's cosine x.
This is just cosine x, right? So that's just going to give us cosine x for the first bit. So we're going to evaluate the limit for that first bit. And then we need to multiply by the limit as h approaches 0 of this 2 sine h over 2 over h, right?
Yeah.
All right. So let me quickly write that. And because, you only just did it today, and this is, it's not too hard, but you haven't done any questions on it before. So we're basically now going to use the fact that the limit as, x approaches 0 of, sine x over x equals 1. We're going to use this, all right?
Yeah.
Now, whenever you do questions like this, you need to make this match. So the thing inside this sine is not just h, right? It's an h over 2, right?
Yes.
So we need to make the denominator h over 2, all right? To
Yeah.
use this rule, yeah?
Yeah.
So think of it like, think of it like a y. So y equals h over 2. So I need to make the denominator y. So I'm going to deliberately make that happen. So the sine of h over 2, because the only way I know how to do it is to make this h over 2. But if I make that h over 2, I need to balance it out by multiplying by 2, right? So, I don't actually change anything. I just change the way it looks, right? Yeah?
Yeah, that makes sense.
But of course, there's still a 2 at the top from before.
So we just eliminate.
Yeah. So this is the 2 that I added. There's a red 2 that I add to sort of make that cancel with that.
Yeah.
But of course, these cancel. And so really, this will just become the limit as h approaches 0 of sine of h over 2, all over h over 2, which if you prefer, I mean, it should be fairly obvious, but it's a bit like y approaching 0 of sine of y over y.
Yeah.
Which is just 1.
Yeah, that makes sense.
Which therefore means that this is going to be cosine x times 1, which is cosine x.
Yeah.
And therefore, that is how we would prove, putting all of those parts together, the derivative of sine x is therefore equal to cosine x.
Yes, that makes sense.
Now note, x is in radian. That's important to note.
Yeah.
Good. Any questions with that?
It's all good.
Great. So we haven't really had any chance to sort of talk about the proofs for the others, but we won't do it to that level of detail again. We'll just kind of cheat. Well, not really cheat, but we'll just work with what we've already got in later lessons to kind of prove the cosine and the tan.